Alright, today I will talk about secant lines. In my previous video, I talked about tangent lines. So let's recap that. A tangent line is a line that intersects with a circle at exactly one point. So think of it as a line that's sitting on a circle. This is your tangent line. So now what we have is a secant line, which is a line that intersects with a circle at exactly 2 points. 1, 2. So this is called a secant line. Right? Now, as far as tangent lines and secant lines are concerned, there is this formula that we use. That is, right here is your angle equals a relationship. Angle equals, over here, let's call this part my far arc, and this part is my near arc. So we're talking about the two arcs inside that angle. So what we have is angle equals the far arc minus the near arc divided by 2. This is a formula that we used in the previous video. Whether you have two tangent lines that intersect outside the circle, let me write that down, or over here, two secant lines that intersect outside the circle, or over here, one tangent line and one secant line that intersect outside the circle. This formula will always hold true, that your angle where those two lines intersect equals far arc minus near arc divided by 2. And there's a way to rewrite this formula, that way we don't need to worry about fractions. So a second version of this formula is 2 times the angle equals far arc minus near arc. So let's use these formulas in solving some of my sample problems over here. Zoom in. Let's work on this. So first, I want to do a recap of things that I have covered in a previous video. In a previous video, let's take a look at this example. Over here I have my inscribed angle and my intercepted arc. And as a property of circles that I've covered before, we know that inscribed angles equals half my arc. So let's call this angle x. My inscribed angle x equals 1/2 of 120, which is 60. So this is a recap because we are solving for angles and arcs of a circle. So inscribed angles and central angles, we still need to remember them. Right. Let's take a look at this other question. So same concept, inscribed angle equals 1/2 your arc. So we have my inscribed angle, 10x minus 5 equals 1/2 my arc, 1/2 of 210. Solving for x, we have 10x minus 5 equals 1/2 of 210, 105. Add 5 to both sides. And finally divide by 10. Get x equals 11. So your inscribed angle equals 1/2 your arc. That's something we will be seeing here. Now let's take a look at secant lines and tangent lines. Number 8. So we have that formula given to us earlier of how right here is my angle in orange. Angle equals my far arc over here in purple minus my near arc over here in green divided by 2. So let's plug in our information in this formula. My angle is 40 equals far arc of 140 minus near arc. This entire 5x plus 11 is my near arc. Because it's a whole thing, I need to put that inside parentheses. 5 plus 11x go together. Divided by 2. Solving for x, I can multiply 2 on both sides. Getting rid of the fraction, a trick is to multiply by that denominator. So 2 times 40 equals, so we have equal sign over there. (140) minus 5 plus 11x. So I have 80 equals 140. Notice you have this negative in front of a parenthesis. Let me make a note of that. Negative in front of our parentheses. We have a negative in front of our parentheses. What this means is that negative sign has to distribute. We distribute. So what we're going to have is minus 5 minus 11x. So that plus 11x turned into a minus. Be careful about that. Combining like terms. Got negative 55 equals negative 11x. Last step, divide by negative 11. That x equals 5. So be careful about subtracting that near arc. This entire near arc needs to go in parentheses. So we end up having a negative in front of a parentheses that you then have to distribute. Alright, moving along. Last one I'll do is over here, 16. Just get some more practice. Alright, again, we still have our formula. That has to do with angle. near arc, and far arc. So formula is angle 4x plus 1 equals far arc 12x minus 2 minus near arc of 40 divided by 2. Angle equals far arc minus near arc divided by 2. In this case, near arc is just 40, so we don't have to worry about the parentheses. Alright. In our formulas that we wrote down, over here, I'm using this top formula. We could also take a look at the second formula, 2 times the angle. Equals far arc minus near arc. So really, second formula comes from just multiplying the first formula both sides by 2. Or the way I explain this is to get rid of that fraction. Instead of worrying about that fraction in the beginning, you can go ahead and double the left side, and the right side won't have a fraction anymore. So let's continue. We distribute to get 8x plus 2 equals 12x minus 2 minus 40. Combine like terms. I want to go ahead and move the 42 over. That way I don't have a negative sign right there. And then we subtract 8x and moving the 8x to the right. And last step, divide by 4. Now this question did ask for JS, this arc in purple right here. So, knowing that x equals 11, we can plug that in JS, which is 12x minus 2. So, 11 minus 2. This gives me 132 minus 2, 130 degrees for JS. Alright. So here you have that whenever we have secant lines, let's recap. Your angle, here in green, equals far arc minus near arc divided by 2. Or, a second way of writing that formula, 2 times your angle equals far arc minus near arc. The second way lets you get away without having to worry about fractions. Then, a few things to remember. Whenever you have these expressions right here, angle 40 equals far arc 140 minus near arc. Whenever your near arc has more than one thing in it, this entire near arc needs to go in parentheses because we are subtracting a minus sign in front of a parentheses, a negative in front of parentheses changes our sign, so be very mindful about that. And then after you solve set up equation, solve for x as usual. Right? And that also we cannot forget about inscribed angles, that the inscribed angle is 1/2 your arc. So here's my example. Your inscribed angle 10x minus 5 is 1/2 of that 210-degree arc. Set up your equation and then solve for x. So here's that and that.